and welcome to Python Level 2. In this section, we're going to be covering some more advanced topics that will really allow you to use Django with ease. Knowing these topics before you actually reach Django is going to make the transition to using Django very smooth, and you won't get hung up on some of the more complicated aspects of Django, such as object-oriented programming, using classes, or regular expressions. Okay, let's get started. I'll see you in the next lecture. And welcome to Part 1, Scope. We've already discussed scope a bit in the past, specifically in the JavaScript section of the course, but Python's scope rules can sometimes confuse beginners. So let's quickly go over the key rules of Python's scope. Python's scope follows the LEGB rule: local, enclosing function locals, global, and built-in. And what this actually means is if you define a variable name somewhere in your code, and then later on in your code you want to call that variable, Python needs to look in what's known as the namespace, which is basically where it knows what variable names go where. But sometimes it needs to follow rules to know what scope you're actually calling. And the order it goes in is it first looks for local variables, then it looks for enclosing function locals, then it looks for global variables, and then finally, if it still can't find that namespace, it goes to the built-in. So let's actually define these four topics a little more. So the local level are names assigned in any way within an actual function. And that includes a def function or a lambda expression. And they're not declared global in that function, meaning they don't use some sort of global keyword call. Then we have the enclosed function locals, and that's names in the local scope of any and all enclosing functions, def or lambda expressions, from inner to outer. And that has to do with functions within other functions. Then we have the global level, and those are names assigned at the top level of a module file or declared global in a def within the file. And that again is either at the top level or using the global keyword. Then finally, if we still can't find that variable name, we look into the built-in level. And those are names pre-assigned in the built-in names module. Things such as open, the range function, a syntax error, or even things such as the len, which is the built-in length function. Okay, let's actually walk through some simple examples to make Python's scope a lot more clear to you. Let's hop over to the editor now. Okay, to begin our discussion of scope, let's start off with a simple experiment. Imagine at the top of a file, I define x to be equal to 25. And then I'm going to create some function. We'll call it myfunc. It doesn't take any arguments or parameters, but what happens is it sets x equal to 50, and then what it will do, it's going to return x. So that's what it does. And then what I'm going to do outside of this is say print x. So take some time and think what the actual output is going to be when I run this file. So I will say python notes.py, hit enter, and I get out x is equal to 25, or just 25. Hopefully that makes sense to you, because we haven't even run this function yet. All we've done is defined it. The only thing that x here on line 7 is aware of is the global x, which is up here on line 1. Now let's imagine this. We say print, and I call myfunc inside of that print statement. And remember, this myfunction returns x after reassigning it to x is equal to 50. Now if I save this and run it, what do you expect to come out? Well, hopefully you expected 25 and 50. So that actually makes sense, because remember, line 7 is looking at the global x, and then if I call myfunc, it redefines that global x 25 to be equal to 50 only inside the scope of the function, and then returns x, which in this case, it will print out 50. Now sometimes what confuses students is this third line. What happens if I say print x? And what happens if I say print x after I call myfunc in this manner? So let's comment these out and see what happens. So take some time. What do you expect to happen here on lines 9 and 10? I'm going to run this and we'll see. I get x is equal to 25. Hopefully that's what you also expected. If you expected x is equal to 50, let me quickly explain why that didn't happen. And that has to do with scope. When we redefine x is equal to 50 inside of a function, that reassignment is limited to the scope of the function, meaning it doesn't actually do the reassignment in what's known as the global namespace. And that has to do with those scope levels. Remember, it goes local, enclosing functions, global, and then built-in. So here, when we call my function, x is only being redefined inside of this function namespace. And then when I say print x, it's going to call this global x, because it really has nothing to do with this function call. Okay, so let's see some more examples of LEGB, that scoping level, in order to really understand what's going on here. So that's our little experiment to kind of introduce the idea of scope. But let's go ahead and create a lambda expression. This will begin to show the very first level, which is the local level. So if I have a lambda expression that looks something like this, lambda x to the power of 2, this particular x is local. So this is a local level. Now let's show you enclosing function locals, and this is the next level. So this occurs when we have a function inside of another function, which is known as nested functions. So again, for this lambda example, you would probably have this inside of another function, but let's show you enclosing function locals, this next level. I'm going to create a variable called name and say this is a global name. And the reason it's global is because it's not inside of any function. It's at the top level of this .py file, which is sometimes also known as a module, although we haven't really saved it as a module and aren't calling it in another .py file. It's just a simple .py file, but it is outside of any function, so it's at the global level. Now, I create a function called greet. And inside of this greet function, I'm going to assign name to be Sammy. And inside of this function, I define another function called hello. And then I say print hello plus name. Then outside of all these functions, I'm going to call greet. Let's save this, and hopefully you will know when I run this what's going to happen. So I will say python notes.py. Take your time, and before you actually run this, think about what you expect to happen. Note here that I'm calling greet. Think about, does greet return anything or perform any action? So we hit enter, and we get nothing out. And that makes sense, because so far, greet, all it does is it reassigns name equal to Sammy in its function namespace here, and then it has a function defined inside of it. However, no function is actually called inside of greet. If we want to actually print hello plus Sammy, I have to call hello. So I've only defined it so far. And look here how I'm calling hello lined up with its def call. If I did this, call hello within the function hello, that wouldn't make any sense. It wouldn't know what hello is, and you'd get an error there. So we're going to do this, and now let's see what happens when I call python notes.py. I get hello Sammy. So note how Sammy was used, because the hello function was enclosed inside of the greet function. So what's actually happening here? I have this global variable, name. Inside of the greet function, I reassign name to be equal to Sammy. I assign hello being equal to print hello name. And the most outer level it first looks for name is right here, inside this enclosing function. If I put a hashtag here and comment this out, then it's not going to find name outside of it, so it's going to look at the next level, which is going to end up being global. So now let's run python notes.py, and we should see, hello, this is a global name. And there it is. Hello, this is a global name. So you can see here the different levels of where Python is looking for variable names in the namespace. And that's really the whole point of scope, knowing what variables are going to be used if you have things like nested functions. And it's always important to remember, and this is sometimes a point of confusion, it doesn't matter if inside of a function scope I redefine name. If I go back outside of this function completely and ask to print the name, it's going to find it here globally first. It's not going to be able to go inside a function and look for it because it really has no business going inside the function until it's been called. And even if the function's been called, that variable namespace is only here in this local function scope. So let me run this, hit Python notes, and I see hello Sammy. This is a global name because I said name is equal to Sammy. So greet in its scope, when it calls hello, name is equal to Sammy. But when I say print name, it goes to the global one. Name, this is a global name. Okay. Now beyond this, there is the built-in level. And the built-in level is just things that are already built in. So things like len. Basically, anything that pops up in this list here to help you out is built into Python. And these are things that you never want to actually redefine. You would never want to say len is equal to 23. Otherwise, you're never going to be able to call the length function again. You would have accidentally redefined it in the global space. So again, these are built-in function names in Python. You should never overwrite these, and you will know what you've typed based off the syntax highlighting and based off the fact that it's already trying to help you finish that statement before you've even defined it. Okay, So let's talk a little bit more about local variables. When you declare variables inside of a function definition, they are not related in any way to other variables with the same names used outside of the function. And that's a key point I keep repeating myself on. So variable names are local to that function, and this is called the scope of the variable itself. All variables have the scope of the block that they are declared in, starting from the point of definition of the name. So let's show you another example, and this is going to seem like a repetitive example, so if you kind of already get it, maybe you can continue off with this lecture, going on to the next one. But if you're still a little confused, let's show you a couple more examples. So I'm creating a function, and I define at the top globally that x is equal to 50. And then I say def, take function x, and I'm going to say colon here, print x is, and then we can say comma x there. This is kind of like a fast way to print something. And then I will say x here, redefine it to be 1000, and then after that I will print x local x change to comma x. So I will save this, and then outside of this I will call func x. Save it, and then if I hit python notes.py, note here it says x is 50, so since it hasn't found anything redefining x before line 4, it goes to the global space. Okay, x is equal to 50. Then locally, we redefine x to be 1000, and it says local x changed to 1000. But here's the main catch. If I say, outside of this function, even after the function's been called, print x, and I run this, you get back to 50. So here, if we're in the global namespace, we're going to look for things in the global namespace. So the first time that we print the value of the name x with the first line in the function's body, Python uses the value of the parameter declared in the main block, above the function definition. Next, we assign the value there, x, to 1000. And the name x is local to our function now. So when we change the value of x inside of that function, the x defined in the main block remains unaffected. And what I mean by main block is the x up here. So with that last print statement, what we're actually doing is we display the value of x as defined in that main block, thereby confirming that it's actually unaffected by this local assignment. Now let's say you're in a situation where within inside of a function, you actually want to change the global x. So far, it seems like you're only limited to changing the local x. What if you actually wanted this function to reach out, go to the global level, and rename x here to be 1000? How can we do that? Well, the way you can do that is with the global keyword call. Now, as a quick note, it's recommended that you try to avoid using the global keyword call, because doing this, if you have a really long line of code or a really large file of code, can really mess up your namespace if you're not super careful about it. So again, I'm showing it to you here, but I don't recommend that you ever actually use the global name or global keyword unless you really have to. But basically, what the global keyword does is it says, hey, I'm going to be using the global x. So when I call x here, I want to actually reach out to that global namespace, grab that x, and then play around with it inside here. So if I say def func x and declare global x, and we're actually going to not even take any input here, we'll just say call the function, grab x from the global namespace using that global keyword, and then say x is equal to 1000. Then I'm going to save this, and here what I'm going to do is say print before function call x is, and then say comma x. And let's comment these two lines out for now. So all I'm doing here is I've only defined this function, I'm never actually calling it, I'm just saying x is equal to 50. So we would expect this to say print before function call x is equal to 50. So I run python notes.py, and it says before function call x is equal to 50. Now I'm going to call function. And note here, inside of this function, I'm calling global x, which allows this function to reach the global namespace and grab that x. Then, after this, I'm going to copy and paste this, put it here, and then say after. Save it, run this, and note what happened. It says before function call, x is 50. After the function call, x is 1000. So now, with this global keyword, I've been actually able to rename or redefine or reassign something in the global namespace. So now that x is equal to 1000 is actually causing that effect to be permanent. Again, if I do something like this, comment this out, and I just say x is equal to 1000, then if I run this, I get twice x is equal to 50, x is equal to 50. So that global keyword allows you to reach out to the global namespace and actually clarify that, no, I do want to reassign that global variable x. Again, this can be really confusing if you end up having a bunch of global calls all over your .py script. So it's recommended that you try to avoid global. Instead, what you should do is use return keywords. So if you actually wanted to send back an x, you wouldn't want to say x is equal to 1000. You'd want to say x is equal to 1000, return x. And then with that return statement, you can use it in the global namespace. So then you would say something like x is equal to func, and then run something like this. And here we get 51,000. So this use of the return statement has pretty much the same effect as if when we had the global keyword without any of the risk of accidentally redefining something in the global space. Okay, so that's all we really need to discuss about scope in Python. We won't see such complicated examples when we're working with Django, but it is something I want you to be aware of as you continue to program. If you have any questions, I definitely suggest you check out the part 1 scope.py script, which has full notes and many more examples of what we covered here. Always feel free to post the Q&A forums if anything confused you. Thanks everyone, and I'll see you at the next lecture. And welcome to part 2, object-oriented programming. Object-oriented programming is a way to use Python to create our own objects. And sometimes it can be a point of great confusion for beginners, and mainly because it's often just taught poorly. You're kind of just thrown into object-oriented programming, taught a few keywords, and expected to understand everything all at once. We're going to try our best to save you from any confusion by systematically building up and showing you slowly the thought process behind object-oriented programming, otherwise known as OOP, and why we'd even need to use it. We will use it quite a bit for Django, so let's get started by showing you the basics. This is going to be a single .py file for the notes, part 2 object-oriented programming.py, but it's going to be multiple video lectures. So keep that in mind. We're going to break it into understandable steps. Let's go to the editor now. All right, let's start off by trying to understand the fundamental idea behind object-oriented programming. Why would we even want to use it? Well, hopefully you remember when we were first learning about basic data types and basic structures, I could do something like this. Say my list is equal to 1, 2, 3. And then when I said my list dot, notice that I get a bunch of methods here: append, count, extend, pop, remove, etc. So there's a lot of methods available to me on this object. And then I could say append 4 here, save this, and then do something like print my list. I save this, run python notes.py, or whatever file you have, and I get 1, 2, 3, 4. Now the idea behind object-oriented programming is this. So far, we have the capability to create a very simple function or even a very complex function. What we don't yet know how to do is build something like a list object. We don't know yet how can you build an object and then have methods inside of it or attributes inside of it that you can use to affect the object itself. And that's the whole idea of object-oriented programming. How are we able to actually create our own objects in Python? We know how to use the built-in objects in Python, but we yet don't know how to actually build our own. And the first step on your journey of learning about object-oriented programming is to realize that in Python, everything is an object. And you can check an object type by saying type, and then passing in an object itself. So for example, if I pass in a list here, I don't have to save it as a variable, I can just say type, and let's print out that type. So I will say print type here. It tells me it's of the class list. And class is going to be one of the keywords we use when we're actually learning about object-oriented programming. So here, I know that this is type list. And I don't even actually have to have anything inside of it. It can just be an empty list. I can run this, and it'll say class list. And if I replace this just to be parentheses, remember that's how we define a tuple. So if I save this and run this, it says class tuple. And we can see this for a variety of things. Let's say I pass in a number, type, make sure my parentheses are balanced there, and I run this, it'll say class int, or class integer. Make this 20.0, save this, run this, and it says class floating point. So what we want to know is how can we create our own classes in order to create our own object. So we keep seeing this keyword class, and we want to know how can we use it. So let's actually show you. So now that we understand everything in Python is an object, we can use the class keyword. And the user-defined objects are created using this keyword. The class is essentially a blueprint that defines the nature of a future object, and from classes we can then construct instances of that class. An instance is just a specific object created from a particular class. So for example, previously we created the object myList. That was an instance of a list object. Let's see how we can actually use class. First off, you start with the class keyword, and if you hit enter here, you'll get class auto-completed for you. Let's create a sample class. And note the syntax highlighting here, and by convention, class names are always capitalized. That way you know whether you're calling a class or a function. Functions are lowercase, classes start with an uppercase. Then we have close parentheses, colon, and then what goes here in your class. Right now, I'm going to use the pass keyword to not do anything. We'll just say pass. So I'm going to save that. And then over here, I will say x is equal to, and I will say sample, close parentheses. And then I'm going to print the type of x. Save this. Let's run it. And here it says class main.sample. And we'll discuss what main is in a future lecture, but right now we can see that I'm getting a very similar result to what I saw previously with the built-in classes. I've now created my own class and my own object called sample, all using the class keyword. Alright, that's it for this lecture. So far, all I want you to understand is that everything in Python is an object, and we can create our own objects using the class keyword. And we can check with the type built-in function what the actual class is. Coming up next, we're going to learn how to add attributes and methods to a class. And we're going to start right where we left off in this video. I'll see you at the next lecture. Everyone, and welcome back to where we left off last time. So last time we created this sample class. It's very simple, it just has the pass keyword. But really what we're going to have in classes are attributes and methods. Attributes are characteristics of an object. Methods are operations we can perform on the object. So for example, what we will be doing is creating a class called dog. And an attribute of a dog may be the dog's breed or the dog's pet name. While a method of a dog can be something like the bark method, which will return a sound. We can say print woof woof, something of that nature. So let's start off by learning about attributes. So I will make this class be dog. And then let's change sample to be dog here. And let's say instead of lowercase x, we'll call this my dog, kind of like the same way we created something called myList. And then let's check the type of my dog. So we'll save this, run python notes.py, and here I can see class main.dog. So far, so good. So what we need to do is start off with attributes. The syntax for creating an attribute is self.the attribute name equals something. But there's a special method. So whenever you have a class, what you're going to be doing is defining methods inside that class. And the methods look like functions inside of a class. So we start off with the def keyword, and then a special method has a set of underscores surrounding its name. So we say underscore underscore init underscore underscore, then we pass in self, and then we can have a colon here, and here I will just put in pass. So this is the most basic special method you can have, the init method, and that stands for initialization. And this self keyword is always necessary. Basically what the self keyword here does is it tells that this method refers to itself being the actual class object. So if we save this and run it, we shouldn't see anything else different pop up. So we still have class dog. What we're going to do now is inside this initialization method, this init method, remember it has two sets of underscores surrounding it, defining it as a special method. What we do is we add more attributes. So for instance, let's add in breed. So dogs can have a breed. And then what we do here is we have the syntax that looks like this. We say self.breed is equal to breed. And this is where it can get a little bit confusing. So what we will do is run this, and we should expect an error to pop up. And it will say init missing one required positional argument, breed, which now means whenever I create an instance of a dog class, I require breed as an argument. So here we say dog, let's provide it a breed. So we will say create a dog with the breed, and we'll pass in a string called lab. We save this, run this again, and now I see I have class main dog. So what we're going to do now is instead of printing the type of my dog, since we know now that it's always going to be a dog class, I'm going to say print my dog dot breed. And then if I run this, notice I get back out lab. And also note that I don't have closed parentheses around breed. I don't have something like this, and that's because it's an attribute. It's not a method. I don't want to call it to action. I just want to report back what that attribute is. So let's break this all down one more time. We have that init method, and it's called automatically right after the object has been created. So once we initialize the object, we actually call this method automatically. And then each attribute in a class definition begins with a reference to the instance object. And that, by convention, is this self keyword, which is basically saying refer to this particular instance of this object. The breed here is the argument, and the value is passed during the instantiation or initialization of the class itself, where we say breed is equal to lab here. And now we've created an instance of the dog class. So let's create one other instance. We can say other dog is equal to dog, breed equal to, and we'll say husky. Save that, and then let's print out the other dog dot breed. Save it, we run this, and we see we have lab and husky come out. Now let's practice adding one more attribute. So I'm going to get rid of this other dog, and we'll just stick with my dog. Get rid of this other dog as well. And this dog, or dogs in general, won't just have breeds. Let's say they have names. So it's kind of like a pet name. So what we do for every attribute, what we do is we say self dot, and then the name of that attribute is equal to name. And again, what this is doing is it's saying self, which refers to this dog, dot name, so the attribute name for this dog is equal to name, which is going to be the name here. So again, this name on the right-hand side of the equal sign refers to the input name. This self.name is kind of assigning the dot name to the initialization of that dog. So now, if I save this and try to run this, I will get an error because I need to provide a name. So it says init is missing one required positional argument, name. So let's give it a name, and we'll name this Sammy, which is my real dog. Now if I run this, I get lab, and I can also print out my dog's name. So we'll say my dog dot name. Save this, run it, and now I see lab and Sammy. And usually when creating an actual instance of an object, you won't specify breed is equal to something, name is equal to something, unless you want to really specifically target that, so you come back to your code and read, oh yeah, lab stands for breed, Sammy stands for name. If you're really comfortable with an object and you tend to use it a lot, what you'll end up seeing is something more along the lines of this, where you just say lab and Sammy. They have to go in the correct order to be assigned to breed and name, but you'll most likely see an instantiation of an object look like that. And if I run this code, I get back the same thing, lab and Sammy. All right, that's the very basics of attributes. Again, if you have any questions, feel free to post to the Q&A forums, but I also recommend that you check out the Part 2 Object-Oriented Programming.py, which has a lot of notes and a lot of explanatory text for everything we're doing here. Next, I want to talk about class object attributes. So class object attributes are always the same for any instance of the class. So for example, for a particular dog, you may have a different breed or you may have a different name. However, all dogs are mammals. Regardless of their breed or regardless of their name, they're always going to be a mammal. What we can do in that case is add what's known as a class object attribute. And a class object attribute goes outside of any of these special methods or normal methods at the very top. So we'll say class object attribute to point it out. And then I can say something like species is equal to mammal. And if you study biology, you know that species doesn't actually relate to mammal. It's more of the class of Mammalia, I believe. But cut me some slack here because I can't really use this class keyword. So we'll just say species is equal to mammal, regardless if that's biologically correct. All right, so now I'm going to save this. I run this again, and I see lab Sammy. So no, I haven't actually defined species is equal to mammal here. That's taken as a class object attribute to be true, regardless of what kind of dog I have. So whether it's a husky, a lab, regardless of what his name is, if I say print my dog dot species, I will get back mammal, which makes sense. Regardless of whatever I want the breed or name to be, this class object attribute will always be true to be equal to mammal. Okay, now let's move on to actual methods. Methods are functions defined inside the body of a class. They are used to perform operations with the attributes of our objects, and methods are essential in encapsulation concepts of the object-oriented programming paradigm. And this is essential in dividing the responsibilities in programming, especially in large applications. And basically, methods are kind of the whole point of why you would want to even create your own object. So let's kind of delete all this and show you some more examples of how to create a class, not just with attributes, but with methods themselves. So I will create a class, and I will call it circle class. And I'm going to give it a class object attribute where pi is equal to 3.14. Now there are ways to call pi from the math library in Python, but we'll just ignore that for now. We'll say that regardless of what kind of circle you have, the pi, that special number, is always going to be equal to 3.14, or estimated. Next, I'm going to create my initialization special method. You're always going to have this, so we'll say underscore underscore init, so initialize, with self, and every circle, in order to be defined, needs a radius. So we'll say radius. And if we want to be instantiated with a default parameter, just like we could with a normal function, I can say equals 1, which means if I don't provide a radius, I will provide the default value of 1. And since I have radius there, I need to say self.radius. So self.radius, which means this circle.radius, is going to be equal to the input radius. Now let's create an instance of circle. We'll call it myC is equal to circle, close parentheses, and then I'm going to print myC.radius. Save that, run our notes, and we see here my radius is 1. Perfect. Okay, so let's show an example of a method. And remember that methods are functions defined inside the body of a class. And basically they're going to allow us to perform actions based off the attributes of the object. So let's create a method that calculates the area of a circle. We'll call it def area, and we need to pass in the keyword self, S-E-L-F. And that basically tells this method area that it's not just some free-floating function inside of this class, it's actually a method of that class, and that's what the self keyword is doing. Then I'm going to calculate the area. And remember that the area of a circle is just its radius squared, so radius times radius, times pi. But here's an issue if I just type this out. This is a common mistake that beginners make. They type radius times pi, and they think they're good to go. But the problem here is, what radius are you talking about? Are you talking about this circle's radius or some variable called radius? The way to make sure that you know you're talking about this circle's own radius when you actually instantiate it is you need to say self.radius. And that tells this method, hey, look at the object's current radius and call it self.radius. And I need to do the same thing here. And then since pi is an object level attribute, what I can do is say circle.pi. And now if I save that, let's create a circle, myC, with the radius equal to 3. If I save this, run this, I get back out as my output 3, which makes sense. Now let's see what happens if I call area, and let's call area with no open and close parentheses, just area like this, and see what happens. I hit enter, and I get an interesting line of output. I get that I have a bound method, circle.area, of main circle object at this kind of sequence of letters and numbers. What this actually means is this. If I just call .area, that is a method bound to the circle class. And it's a particular instance of the circle class object located at this position in my computer's memory. If I actually want to execute this method, I need to, just like I would for a function, have a set of open and close parentheses on it. Then when I run this code, python notes.py, I see here that my area is 28.26, or estimated to be, given that we're using 3.14 as our value of pi. Now let's imagine that I want to have a method that allows me to reset the radius. So there's two ways you can change attributes of a class in Python. One way is to just call it directly off the object itself. So we can say myC.radius is now equal to, we'll put in 100 to make it really obvious. And then if I call myC.area, we'll get a different answer. So if I run Python notes this time, I get 31,400 because I redefined the radius. Sometimes you actually just want to have a method in order to redefine something like that so that it's really clear. So let's make a very simple method that says set radius. It'll take in self, and then it will take in some new parameter. which will be something like new r. And then I will grab my current radius, which is self.radius, and set it equal to new r. And note that I'm not returning anything. And that's okay. Not all object methods need to return something. Some object methods just affect the object in place. So now, instead of saying my c equals, or my c.radius is equal to 100, what I can do is say my c.setRadius, and then pass in that new r value, 100. And this, well, just to show that this is working, let's pass in something like 999. So when I run this, I get some huge number here. So that's one way you can create methods that reset object attributes. It's sometimes more common to see it the way we first saw it, with my c.radius is equal to something else. Sometimes, depending if you have a really large file, or you work with people that you really want to make sure they're doing things correctly, you set it to a particular method. It's really up to you. That's more of a programming choice. Programming style choice, that is. Alright, so far we've covered methods and attributes. In the next section, we're going to be covering inheritance of different objects, and then we'll discuss some special methods. Thanks everyone, and I'll see you at the next lecture. If you have any questions, feel free to post the Q&A forums, and I'm happy to help you out. Everyone, welcome back to where we left off last time. In this lecture, we'll be discussing two topics, inheritance and special methods. Inheritance is a way to form new classes using older classes that have already been defined. That way, the newly formed classes are called derived classes, and the classes that we derive from are called the base classes. So you derive from the base class. Important benefits of inheritance are code reuse and reduction of complexity of a program. That way you don't have to constantly be creating duplicate classes. You can just inherit from another class and use some of the methods that are available there. So let's see an example of this. I'm going to create a base class, and this base class is going to be called animal class. And the animal class, it needs its initialization method. Remember, that's a special method in it. And here we'll just have self. And then we'll say print animal created. So we're doing a very simple class just to show kind of the idea behind inheritance. Usually you won't have a print statement inside of the initialization method. You'll just have self dot and then all your attribute assignments. Then I'm going to create another method called who am I. And we'll call it self, and then this is going to print animal. And then here I'm going to say eat. This will also take in self, and then this will just print eating. That needs to be a string. Alright, so a very simple class. It just prints things. When you call these two methods on it, it prints something else. So let's actually kind of play around with this and explore it a little bit. I'll make an animal. We'll call it, say, my a is equal to animal, instantiate that, and then let's have it say something like my a dot who am I, and then my a dot eat. And note, I don't have to wrap this in print because the print is already inside of these two methods. So let's call python nodes.py, and I see here animal and eating. Perfect. All right, now let's say I want to create a new class of dog. Now, all dogs are animals, so I want to inherit from the base class of animal. So what I'm going to do here is instead of just passing nothing in these parentheses, I will pass in the other class, which was animal. And I don't have close parentheses here. I'm just passing the whole class in there. And then I'm going to say def init, pass in self, and then when I actually create the initialization, I'm going to call animal dot init, and then pass in self here. And then I'm going to print dog created. So we will save this. And then notice when I ran this the first time, it said animal created, animal eating. So that was for when I created an animal, it said animal created. When I said who am I, it said animal. When I said eating, it said, or when I said eat, it said eating. So what I'm going to do now is save this. And then I'm not going to create an animal. Instead, I'm going to create a dog. And then we'll have this be, let's say it's my dog, who am I, and then my dog here. Now when I save this and run it, python nodes.py, expand this so we can see the output here, it says animal created, dog created, animal eating. So that makes sense because when I created a dog, I said animal here in it self. So it means initialize an animal. And then I'm going to say print dog created. And I don't actually have to have this initialization line. So I'm going to comment that out. And now let's actually see what happens when I run this. It says dog created, animal, eating. So note that even though the class dog does not have whoami or eat methods inside of it, it was able to inherit those methods or derive those methods from the base class of animal. And that's basically the entire idea behind inheritance, is the fact that you can inherit from another class or derive another class. And then you can see here, I can call whoami and eat, even though they're not strictly defined inside of this dog class. Now I can also create new methods here. So I can say something like bark, it takes in self, and then it says print woof. So now I can go all the way down here and say my dog dot bark, close parentheses, and when I run this, I should be able to see my new class wolf. Now I can also overwrite classes, so I'm not strictly limited to everything that was an animal. If I want eat to say dog eating, I can do that as well. All I have to do is just say def, and then call eat, pass in self, and then basically write over it. So here I will say now dog eating. Save that. So when I run this again, Python notes, I see that a dog's created, animal, dog eating, wolf. So I was able to successfully overwrite the previous method. And you can check out the notes for more examples of this, but the basic idea I want you to get is that if you've already created a class and you want to use some of those methods in a new class, all you have to do is inherit it like this, and you can then derive from the base class. Alright, so special methods are basically going to allow you to perform special operations, and these methods are not actually called directly, but they're called by specific Python language syntax. Let me show you what I mean by that. Imagine that I create a list, and we'll say my list is equal to 1, 2, 3, and then I say print my list. And if I run this, python notes.py, I see 1, 2, 3. I've printed my list. Zoom a little bit out. Now what happens if I create my own class and try to print it? So I will create a class called book. And this is going to be a very simple thing so far. We'll say def, we'll pass in our init special method, we'll say self, and this will also have a title, an author, and pages. And then what we will do here is say colon and assign those attributes. So self.title is equal to the title, self.author is equal to the author provided, and then say self.pages is equal to the pages provided. Whoops, pages. Great. And now what I will do is say b is equal to book, close parentheses, and then add in the title. So the Python is the title. We also need to add in the author, Jose, and we'll say it's 200 pages long. And I'm going to say print b, print my book. So this is kind of the exact same thing we did here, except notice what happens when I run this. If I say python notes.py, I hit enter. When I print out my book object, it says main.bookObject at its location in memory. So the question arises, what is the print function actually doing, and how can I get it to print out something that looks nicer? Something that says like title, Python, author, Jose, pages 200. Well, what happens when you call the print function on an object is it looks for its string representation. And right now, we haven't actually specifically defined the book's string representation. We need to use what's known as a special method to do that. And all special methods inside of a class are annotated with 2 underscores, the name of the special method, and then 2 extra underscores. And we can see here the syntax highlighting also notes that they're a special method. And they all need to take in the self argument. So this special method, str, is the string representation of my object. So whenever a function asks for the string representation of my object, and the print function does that, it will return whatever I put here to return. So we'll just say return hello. We save that, and now when we run this, we get back hello when I print out my book. And let's delete this my list, since we won't be using it anymore. So realistically, you're not going to want to say return hello, but instead you're going to want to return a string representation that actually makes sense. And for our case, a string representation that might make sense is something like title, and we'll use some print formatting here. Author, and then let's say pages. And then we will say dot format, and we pass in self.title, comma, self.author, comma, self.pages. And we will save this, and let's check to see if we made any errors and if everything runs correctly. Okay, here we go. When I actually called to print B, or print that book, print, the actual function, looked for a string representation, and that was returned by the special method, in which case we got back title, Python, author Jose, pages 200. And this is how you're going to typically see the special method str for string representation used. Now let's show you a couple more useful special methods. So another special method is the len, or length method. So imagine I call len on a list, 1, 2, 3. I know I will get back the number 3, indicating 3 elements inside of that list. But what happens if I call length on B? Well, I can return or save this and run it. And let's actually print out lenb. But notice what happens. I should get an error. And it says object of type book has no length, which means I need to add in a special method, def underscore underscore len underscore underscore, and this is the length method. So underscore underscore, let me make sure I have balanced underscores. Okay, it's 2 on each side. I type in self, and then what I end up doing is returning whatever I want the length representation to be of my book. And a good representation here, the length of a book, would probably be the pages, so I call self.pages. Note that I'm calling self.pages and not just pages by itself. So now let's see if we can print the length of the book without any errors. And we get back 200, which makes sense because that's what I defined here as the length of the book. So what this length function that's built into Python does is it goes inside the object, checks if it has a special method, len, and then returns whatever that method tells it to return. And then finally, one other special method that you may find yourself encountering, and there are a lot of special methods. As you can see here, all of these are special methods, so anything that is wrapped in 2 sets of underscores is a special method. And there's a whole bunch of them, but I'm just showing you the most common ones. We'll explore more as we continue on with Django later on. But delete is another special method you might find yourself running into, and that's just when you call delete. So I will say print a book is destroyed. And the way you can delete an object from memory space is with del, and then whatever the object name was. So now if I run this code, I get back, I created a book, but a book has been destroyed. All right, that's all you need to know for special methods. The most common one we'll probably be using throughout the rest of the course is this one, the str, the string representation. Because if we ever want to print something, it's important that we have the method to do that and not get any errors. All right, thanks everyone, and I will see you at the next lecture where we're going to be walking through a project for you to do to practice object-oriented programming. Everyone, and welcome to Part 3 OOP project. Object-oriented programming is fundamental to becoming a good Python programmer, and we're going to be using it so much in Django that it's great to get some extra practice by building a game. We'll use object-oriented programming to create the card game known as War. It's a very simple card game. The relevant file for this lecture is Part 3 OOP project.py, and there's also a solutions file. Don't check the solutions file yet until you've attempted the project. Feel free to either treat this as a code-along project, where you just go straight to the solutions lecture and actually code along with me, but I do recommend that you attempt it on your own first. Let's take a quick look at the actual project file, which has some extra code to help you out if you attempt to do this on your own. I'll jump to my editor now. Okay, so here I have Part 3 OOP project.py file open, and when you open this file, you'll notice that there's a bunch of commented code. These are just the rules of the game War. If you haven't played War or don't really know what it's about, you can read this to actually understand the rules, or you can actually read the Wikipedia link to War, the card game. But the basic rules are very simple, and the way we're going to do it for this project is you playing versus the computer. What's going to happen is you have a deck of cards, it gets split in half, and half of it's face down to you, half of it is face down to the computer. And you and the computer will flip one card face up at the same time. Whoever has the higher card wins both of those cards. And that's the basic premise of War. But there's a special event that happens when both cards that you pull face up happen to be equal to each other in rank. If that's the case, then you and the computer pull out an extra 3 cards, and then you pull out another card to actually compare to each other. And then whoever wins that wins the war and then wins all of those cards. So that would be all 10 cards. Okay, so then we want to scroll down here, and we can see that I've imported some useful things for you. So I've created already from random import shuffle, And then we have two lists here that are really useful for creating cards. They're just lists that are created by splitting a string based on the white space. So you can play around with those. You don't have to use them, but they're there just to help you out. Then we have the deck class, the hand class, the player class, and then some gameplay. So what you're going to be doing is the following. You're going to be using this deck class, and this object will create a deck of cards to initiate play. And you can then use this deck list of cards to split in half and give to the players. It will also be able to use these two lists here to create the deck. It should also have a method for splitting and cutting the deck in half and shuffling the deck. We also have the hand class, and each player has a hand, and they can add or remove cards from that hand. And there should be an add or remove card method within this class. Then we have the player class, and that takes in a name and an instance of a hand class object. And the player can then play cards and check if they still have cards. And then finally, over here, we'll have gameplay. Again, you don't actually have to use these three specific classes, but you do have to use at least one class and use object-oriented programming in some way. But this is just skeleton code here, just some scaffolding for you to fill out if you want to follow along with the solutions. Okay, best of luck, and coming up next is the solution lecture where we will be coding along an example solution. Thanks everyone, and I'll see you at the next lecture. Part 3 OOP Project Solutions lecture. In this lecture, we're going to be coding through an example solution to the card war game project. Let's hop to the editor and get started. Okay, here we are at the file, so let's scroll down and get started with the object-oriented programming of the deck class. So the first thing we always need in a class is the init special method to initialize this, and it will always take in self. And just to make things obvious, I'll add a print statement in here. You usually don't have print statements like this, but we'll just add it in anyways, and we'll say creating new ordered deck. And then what I'm going to do is say self dot all cards is equal to, and what I could do is have the logic be inside the initialization or have the logic be outside the initialization. So what I mean by that is I'm going to have a global variable here called myCards and set that equal to a list comprehension that is tuple for the suit and the rank of the cards, and say for S and suits for, or suites for R in ranks. So that's one way to do this. You could have also done this with a nested for loop. So just to walk through that example, you could have said something like for R in ranks, for S in suites, and then have some, you could say myCards.append SR, a tuple there, with myCards being equal to some blank list. So this is the exact same thing as this. So keep that in mind. If you need to pause the screen and kind of break down this list comprehension and compare it to this nested for loop, that's all that's happening here. But I could then pass in myCards over here during the initialization step. But instead of doing that, I'm just going to grab this list comprehension, delete this, and then put that in here. Okay, so that actually creates the deck, and it all happens inside the class. Again, you don't have to do it this way. There's many ways to actually do this, but we'll just create the deck here. So that's a new ordered deck. If I want to shuffle the deck, I'll pass in self. And then let's add in a print statement just to make things really obvious since this is a project to learn with. We'll say shuffling deck. And I will call the shuffle function on that list, which is self.allCards. And then I also want to be able to split the cards in half, so I will create a new method, split in half. That takes in self. And then what this is going to do is it's going to say return self.allCards. And I know there's 52 cards in a deck, so that I need to go from the beginning all the way to index 26 up to but not including it. And then self.allCards from 26 onwards. So that will return a tuple of the split cards. Up next is the hand class. So this is the hand class, and each player is going to have a hand, and they can add or remove cards from that hand. So what's going to happen here is I will initialize this with self and then cards. And then I will say self.cards is equal to cards. And then let's also have a method here, a special method, for printing out the hand. So I'll pass in self, and let's return using print formatting contains blank cards, and we'll say dot format, and let's return the length of self.cards. That way I know how many cards is in the player's hand. So that's what's going to happen if I ever print a hand. It's just going to report back how many cards that player has in their hand. Then finally I want the two methods that are add or remove. So I will create an add method, which takes in self and then the added cards. So that's going to be a list. And I'm going to say self.cards dot, and I want to not append, but extend my list with the added cards. So in the middle of the table, they're the cards that the computer played, the cards that you played. That will be a list, and then we will extend that list. Maybe you decided to do it a different way. That's totally fine too. And then we'll have a method called remove card. That will just be self, and this will pop off the top card here. Or the very last card, I should say. Cards.pop. And there we go. Now we have the class player. So let's play around with that. First off, I want to initialize the player. So we'll say underscore underscore init self, and a player should have a name, and they will also have a hand. And then I will say self.name is equal to name, and I will also say self.hand is equal to hand. And let's create some more methods here. I'll create a play card method, and the play card method is going to have a variable called drawn card, which is just self.hand.remove card. So remember, remove card from that hand object, so the player is going to get a hand object when we actually create it. I can call remove card and add card from that hand object, which in my case is just self.hand. So this is sometimes a little bit confusing because you kind of see these multiple calls here, but it's just self.hand.remove card. And then let's add a print statement so we really know what's going on here. I'll say brackets has placed, brackets, and then let's say dot format, and I will say self.name, so that's the player name, has placed, and then we'll put in the drawn card. So whenever I play a card, it will say player has placed, and then whatever card I drew. And then we can also print a new line here. So that way our console, when we're printing a bunch of stuff, doesn't actually get stuffed with a bunch of commands. We can read it better. And then finally, I want to return the card I drew, which is the drawn card. The next method I want is some method to remove the war card. So we'll say remove underscore war cards, self, and then what's going to happen here is I'll have a local variable called war cards, set it equal to an empty list, and I will say for x in range 3. So if both the computer player and you pass two cards and they are the same rank, then we have war. So I'm going to need something to actually remove the 3 top war cards. So I'll say for x in range 3, war cards dot append self dot hand dot cards dot pop. So what's actually happening here? Well, if I match with the computer, I need to grab those war cards, and I will grab them as a list and return them as a list. Then I'll say for x in range 3, which basically means for these 3 cards, take the war cards and append self.hand.cards.pop. And we could have also done that with remove. It's really up to you. There's so many ways to do this that you shouldn't feel obligated to do it exactly like I did it. So here we see hand.cards.pop. What could I have also done is just remove card, which is self.cards.pop. So again, .cards.pop, that should be the exact same thing as me saying remove card. So I could have done with this, remove card. That's the exact same thing. Choose whatever makes most sense to you. Usually you'd probably want to actually take advantage of the method, but we'll leave it the other way for now in case this may be a little more clear for the user, but it's really up to you. And then I also want to have a method here called still has cards, and all this does, and we can add in some documentation here, or a doc string. This will return true if player still has cards left. Because remember, when a player runs out of cards, then the game's over. So what I'm going to do is just return the length of self.hand.cards whoops, that should be a H, is not equal to 0. So that will just return true if the player still has cards left. Okay, so we just created a whole bunch of functions. Let's quickly review all of them. So starting from the very top of the deck. Remember, I have these two helper lists. What I do here is I create this object, self.allCards, and that's just this giant list of all the cards in the deck. Then I can shuffle all the cards in the deck, and then I can split that deck in half. And note, when I split the deck in half, I actually return a tuple, which means I can use tuple unpacking to grab the first half of the deck and then the second half of the shuffle deck. Then I have the hand class, and what this does is it just reports back how many cards I have here in this hand. Then I can add cards to the hand, which is extension, and then remove card, which pops a card off. Then I have the player class. The player has a name and one of those hand objects. They can play a card, which means they just remove a card, and it tells you what card they place down, and then it returns that drawn card. We also have remove war cards, which means if I have war present, then I will call range 3 and remove those cards. Again, I can use .cards.pop, or I can just call .remove card. It's up to you, whatever's more clear to you. Then I have DF still has cards, which just returns true if the player still has cards. So now let's actually say welcome to war and begin. I want to use all three classes to do this, so let's kind of mark down what we have to do first. To do this, what I have to do is create a new deck and split it in half. So let's do that. That should be T there, create. So I'll create a new deck object, set it equal to D. And let's zoom in here a little more so we can see what's going on since we're towards the bottom. Let's make some space for us. So I create a deck object, and I'm going to call the shuffle method on that deck, and that's in place. And then I'm going to use tuple unpacking to grab the two halves of the deck, half 1, half 2, and that's just going to be D.split in half. And then I want to create both players. I'll create the computer player, which is going to be a player object called computer, and then it's going to accept a hand object made out of the first half of the cards. And then for the human player, we want them to provide their name. So we'll say input, what is your name? Question mark. And then we'll call this object user, and that will be a player object with that human provided name, and hand is just going to be half 2. And then basically war essentially plays itself. So it's such a simple game that there's no strategy to it. You just keep flipping the cards, check who won, and then take the cards. And if they match, you play war and then just check who won the war. In that case, let's actually make this kind of automatically play. So I will say total rounds, let's not make this a comment, is equal to 0. And then I will also check the war count and see if that's equal to 0. And basically what I'm going to be doing is automatically playing this game for both the human player and the computer, since they essentially don't have to make any decisions. That's how simple a game war is. We will say while user still has cards and the computer still has cards, we will add 1 to the total rounds. So I will say total rounds plus equal 1. And I will print out time for a new round. And then I will also print out here are the current standings. And then what I'm going to end up doing is saying print user.name plus has the count. And then I actually want to grab how many player or cards are left. In that case, that's just the actual length. So I will say has the count plus, and we'll cast it to a string. There's many ways you could do this. You could also have built in your own str special method inside of this. And we can say user.hand.cards. And we're going to do the exact same thing for the computer. So let's do that as well. But instead of username, it will be comp for computer. And instead of user.hand.cards, this will also be comp. All right, very simple. And then we're going to say, just tell them both, play a card, and we'll print a new line. So that's just the printing setup of the game. We're going to represent the cards that are on the table that's in between the player deck and the computer deck with a list. We'll say table cards is equal to an empty list. And then when we actually play cards, we'll take the computer card, the C card, and say comp play card method. Remember that returns the card. And then we'll also have a player card, P card, and say user play card. And then I want to add that to the actual table cards list, which means I'll do something like table cards.append the C card. We just need to use append since it will be a single card. And I also want to say table cards.append the player card. Then after that, I want to check if there's a war. So if C card of 1 is equal to P card of 1, I'm going to add 1 to the war count. So I say colon, and war count says plus equal 1. And the reason I have to use this indexing for 1 is because remember, if we scroll all the way back up to how we define cards, cards are just tuples themselves. So cards are just tuples that have this suit value and then the ranking. And the ranking is what I want to actually compare. So that's at index 1, which is why, scrolling all the way back down, when I actually have the cards to compare to each other, I want to grab their rankings and compare it to each other, which is why we had that indexing 1. Okay, so that means we have war. So we'll say print war. And then I will grab the table cards, and I'm going to extend the table cards now by user remove war cards. So that just takes the top 3 cards they have available. And then I'm going to do the exact same thing for the computer. So extend comp.remove war cards. So I've grabbed the war cards now, and then I want to check who has the higher rank. So if ranks, let's say if ranks at the index of C card 1 is greater than, or let's say less than, the ranks at the index position of P card 1, we will say user.hand add table cards. And then we'll say else we'll add it to the computer's hand. And this doesn't take into account a double war situation. In a double war situation, we'll just say default the computer wins. Again, you could keep adding more logic if you wanted to. Alright, so let's actually break this down and kind of explain what's going on here before we continue. This first if statement at the very top is checking the computer card's ranking versus the player card ranking. And if that occurs, then I have a war. So I want to say +1 to the actual war count. And I print out war on the console. And then the cards on the table, remember so far it's just 2 cards, the initial computer card and the initial player card. I'm going to extend it with 3 cards from each deck. 3 cards from the user deck, and then 3 cards from the computer deck. And then I will say this. Remember ranks is that very top list where I have all the ranks right here. So the ranks are conveniently in order, which means I can compare the index position, and the greater index position counts for the higher rank. So then scrolling all the way back down here, what I'm doing with this .index call off of this ranks list is asking where is the index for this particular ranking, and where's the index for this particular ranking. So where's the index of the computer card in the ranks list, where's the index of the player card in the ranks list. And if this, the computer card, is less than the player card, then the user gets all the table cards. Else, the computer is going to get all the table cards. So the player is only going to get it when the computer card ranking is less than theirs on that war. Otherwise, the computer gets all the cards. So even in the case of a tie, we'll just let the computer have all those cards. We could add more logic to check for a double war situation, but we won't worry about that for now, just to keep things very simple. And then I need an else statement to go along with this initial if statement. So far, I've checked for war. That's kind of the hard part. The easier part is if there is no war, then all I have to do is directly compare the actual cards. And that's essentially the code I have right here. So I can just copy this and paste it. And that's all I have to do, because in this case, I don't have war, so I just need to compare C card 1 and player card 1, and then add the appropriate cards. And then what I'm going to do after all of this has been done, meaning this while loop has finished executing, so the user still has cards and the computer still has cards, eventually one of them is going to run out of cards. I want to print out how many rounds it was. So I will say print game over, number of rounds, colon, and then we can just say comma, or I can say plus, the string representation of total rounds. And then I can also say print a war happened. I'll say plus the string of the war count. And we'll say plus times. And that way we can report back how many rounds we had and how many times we had war. So let's save this. I have this all under notes.py. Okay, so it looks like the majority of our code is done, but before we actually run this, it's always a good idea to actually kind of do a quick pass over and see if we're missing anything or not thinking of anything correctly. So if I go all the way to the top, we can kind of check on this. I'm saying for random import shuffle, that looks okay. These two look okay. Class deck, let's check all the methods in each of the classes. Def init, self.allCards, and it looks like I'm accidentally missing a in statement here. So for S in suite or suit, for R in ranks, shuffle, that looks okay. Split in half, that one's looking okay. Class hand, init, the string, add, remove cards, that's all looking okay. Player, init, that looks okay. Play card, that also looks okay. Remove war cards. So an issue that may arise here with this remove war cards is that if I end the game on a war, I may not actually have 3 cards left. So what I mean by that is if the computer has most of the cards and you have 2 left, and you happen to draw war, you may get an out of index error when calling for range 3. So let's actually add a little bit more code here to check for the war cards. So I will say if the length of self.hand.cards is less than 3, I will return all the cards, which is just going to be self.hand.cards. So I will just return all the cards as a list. I won't even bother popping anything off of them. And then I'll have the actual for loop become an else statement. So then we can do this. Else, for this, return that. So now let's save this, continue on. Still has cards, that check makes sense to me. Gameplay, we just went through all of that, so it should be okay. We check if both players still have cards, we keep running this loop. We take the computer card, the user card, add them to the table cards. We check to see if there's war, otherwise we just check those individual cards, and then we play the game. Okay, let's run this and see if it all works. I'm going to open the terminal here, and then I have this under notes.py, so I will just call python notes.py, hit enter. Looks like it's starting off okay. What's your name? We'll say Jose. Hit enter, and it looks like the game actually works. So we say game over, number of rounds, 178 rounds, war happened 16 times. And right now we're actually not reporting who won, which isn't so great. So let's actually report back who won. And the way to do that is just report back their length. So we'll print out computer has, and then let's check how we can grab how many computer cards there are left. So that's the comp still has cards. We can actually just report this back itself. So we'll say computer has, well, instead of saying computer has, we'll say the computer. Does the computer still have cards? Question mark. And then we'll print back comp still has cards. We'll just turn this into a string. This will either be true or false. So that will be a string, and then we can do the exact same thing for the player. And this will report back who won. Does the human player still have cards? And this will end up being user. Okay, so let's save that, run this again. Say Jose is the name, and then looks like the computer still has cards, true, so the computer won that time. 130 rounds, war happened 16 times. Let's run this one more time to make sure everything's working. Shuffling the deck, we'll say new, and then computer won again. Let's try to make sure the computer doesn't always win. And great, so the human player still has cards, true. And interesting enough, war happened 0 times, and it was won in just 36 rounds. Okay, great. If you have any questions, feel free to post to the Q&A forums. This is a very challenging project, so if you weren't able to get it on your own, especially given that we just learned about object-oriented programming, don't worry about it too much. We won't ever have to do something this complicated in Django. A lot of that work's already done for us. We just need to know the basics of adding methods to objects. We won't be doing anything this complicated when we talk about Django and building our own web applications. Again, any questions, make sure to check out the solutions.py file and check out the Q&A forums. Thanks, and I'll see you at the next lecture. To part 4, errors and exceptions. Oftentimes, our code isn't going to be perfect, meaning we run into errors. And I'm sure by now you've actually ran into your own errors while trying to code out some of the examples in this course. But you may be wondering also, how do we actually set up our own error and exception calls? Let's find out. The key to all of this are these 3 keywords: try, except, and finally. We can use them to dictate our code logic in case of an error. To show how this works, we're going to be opening files, and one way to open files is to use the open function. And the open function looks like this as a general example, where your first parameter is the actual file or path to the file, and the second parameter is a string code, indicating whether you're just going to be reading the file, writing to the file, or reading and writing to the file. So as I mentioned, that second parameter dictates how you're going to be opening the file. And if you accidentally use the wrong code, for instance, you say you're just going to read the file and then you attempt to write on the file, you may get an error. So we're going to be using this open function to actually show how we can handle errors. Let's hop over to the editor and get started. Okay, so here I am at the editor. To begin with, let's actually show what happens when we make a mistake and actually get an error out. So for instance, let's say I say print here, and I say hello, but for some reason I accidentally cut off that last single quote and messed up. If I try to run this notes.py file, saying python notes.py, and I hit enter, I get a syntax error, and it's EOL, or end of line, while scanning string literal, meaning the line suddenly ended and it expected more here. So that's one type of error you get. Notice it's called syntax error. Now let's say I do another error, where I say something like print my list. And for some reason I forgot to define my list, or maybe I defined my list earlier, but I called it my list here. Set it equal to 1, 2, 3, and later on in my code I forgot it was my list here, and I just said my list. Let's save this and run this. No, I get another error. This one's called name error, saying the name my list is not defined. And basically what this means is that we get these specific errors that are trying to help us out actually figure out what's wrong with our code. And this type of error in description is known as an exception. Even if a statement or expression is syntactically correct, it may cause an error when an attempt is made to actually execute that specific command. Errors detected during execution are called exceptions, and they're actually not unconditionally fatal. And what I mean by the phrase unconditionally fatal is that you can use those 3 keywords we talked about earlier to actually dictate how your code can handle those errors or exceptions and continue on with the rest of the script. That way, if something pops up, you can actually move with the punches and keep going. So let's show you how to use try and except. The basic terminology and syntax used to handle errors are try, except, and sometimes finally statements. Basically, it's code which can cause an exception is put inside the try block, and the handling of that exception is implemented in the except block of code. Let me copy and paste the example syntax from the notes to show you. So I'm going to copy and paste some commented code here. Let's say Control V, there we go. So the general syntax looks like this. You have a try, and you do your operations inside this try statement. And like the keyword kind of implies, you're going to try to do this. You're going to attempt to do it. And then you have except and exception 1. So if there's exception 1, and this exception 1 would be something like this, name error or syntax error. So you're kind of watching for a specific exception. Then you execute some certain block of code. Then you can have another except if there's an exception 2. So that's maybe one check is for a syntax error, another check is for a name error, etc. Then you execute this block. And then else, if there is no exception, you execute that block. So we can better understand this by actually walking through an example. Let me delete all this, and inside of this same folder, I'm going to create a new file. It's going to be a simple text file. We'll say simple txt, and it just says hello world. This is just a normal text file. Save that. And then inside of notes.py, I'm going to try to open this file. So I will say try, and I will say f is equal to open, and we'll pass in simple txt, that's simple text. Now I'm going to open it with the parameter w as my second argument. And then I'm going to write. So I will say test write to simple text. And then I'm going to say except, and I will specify except IO error, which is import output or input output operation error. And this will only check for an IO error exception and then execute a certain block of code. So let's print error could not find file or read data. And then finally we'll say else, and I will print success. And then finally we need to close that file. So the basics of working with a file is you open it, you either read or write it, and then you close it. So let's actually run this and see what happens. So I'll call python notes.py, and it looks like it was a success, so everything's working well. Now let's see what happens if I accidentally, instead of saying with W for write, I said R, which stands for read. And when you open a file with only R, that means you only have reading permissions on that file. You can't write to the file. And what's useful about only saying R is if you want to make sure your code doesn't accidentally write over a file, you make sure to only open it with the R permissions, meaning you can only read it. That way, if you accidentally write to the file, it won't happen. You'll get some sort of error. So let's clear the console and run that. And note here, instead of getting that sort of IO error, I get this, error, could not find file or read data. And that's how this except works. Except can look for a specific error, and then instead of actually outputting what the error would usually output and stopping all your code, it prints error could not find the file or read data, and then we can have an else statement. And then we can actually keep going. So let's say I have something outside of this that says print hello world, save that, run Python notes again. It says error could not find file or read data, hello world. So what this try except clause actually helps you do is handle errors and then continue on with your code. Let's imagine that I didn't actually use try, that I just tried to do this without this sort of block. So I comment all that out, and then I just say fopen simple text, I say fwrite, and then if I scroll all the way down, let's say after doing that, I try to print hello world. If I save this and run this, I get back this IO error, not writable, and I never actually output print hello world. This was fatal to my actual .py file. And the way we can use try and except is to make these sort of exceptions not unconditionally fatal, meaning having your code being able to handle these sort of unexpected, or in this case, expected errors and continue on. And that's really the whole point of this. If you expect something wrong may occur, or you have a certain condition that may actually mess up your code, you can counter it with an except clause. Now another thing you may be wondering is, well, how am I supposed to know what error is going to happen? I can't have all these error codes memorized. You know the basic one like syntax error or name error, but you may not have known IO error or other errors. What you can do is you actually don't need to give any error code. If you just have a general except here, it's going to print on any sort of error. So let's save this and run this again. Python notes.py. It'll report back on error. So you don't actually need to specify the specific error. So a lot of times you're just going to be writing except there. Okay, so now let's introduce the finally keyword. And the finally key block of code will always be run regardless if there's an exception in the try code block. So right now, if you look at our code structure, we have try, which tries to do something, except, which is going to report back this block of code if there's an error here. And then we have the else, meaning if we don't actually have that exception, we'll say else, print success, and then fclose. But what if we actually get an error, but want to continue doing stuff inside of a block of code here? So instead of having like print hello world out here, what we can do is have the finally keyword. So I will add in a finally block, and then I'm going to say print I always work, no matter what. And then let's save this and run this. And we see here, even though we got an error, we always get the finally block to occur. So I always work no matter what. Okay, that's really all we need to know for now about try, except, and finally. As a quick note, these try blocks are not invulnerable to all errors. If you have an error that affects the try block itself, so for instance, if I close this off and I have the try block continuing on, I'm going to get an error here. So if I save this and then try something like python notes.py, I will get here a syntax error. And it's not caught by this except statement because the error is actually affecting the try, except, finally statement itself. So it thinks that all of this belongs to this string and you have some sort of syntax error there. So except is actually being messed up there. So again, you don't actually usually use try for something like a simple syntax mistake. You use it for larger blocks of code that are usually interacted with some sort of user input. That way you can handle any user mistakes that happen to affect your code. Again, the key words to know here are try, except, and finally. Where you're going to try to execute some block of code, you'll say except to try to catch certain exceptions, and a lot of times you're going to catch certain exceptions and print out something that's more useful than just syntax error, invalid syntax. Something useful like, hey, you had an error doing this specific operation, check this out, maybe review this line of code, etc. And then you have the finally block, which always works even if there's an exception. Okay, thanks everyone, and I'll see you at the next lecture. 8. Regular expressions. Regular expressions allow us to search for patterns in Python strings, and they can seem incredibly intimidating at first due to their strange syntax. We're going to be walking through the basics of regular expressions, and we will use them in Django when we talk about URLs. Alright, let's get started. Okay, let's begin with the very basics of regular expressions, and we can start by importing the RE module for regular expressions. And one of the most common use cases for the regular expression module is to find patterns in text. So I'm going to create a list called patterns, and we'll say term 1 and term 2. So these are the patterns I'm going to be looking for. And then I'm going to have some text to actually parse. So we'll say this is a string with term 1, but not the other. So no, it has term 1 inside of it, but it doesn't have the actual other term. And then what I'm going to do is say for pattern in patterns, I'm going to say print I'm searching for, and then I'm going to say pattern. So if we save and run this right now, it shouldn't be anything of much consequence, but let's make sure everything's working. So Python notes.py, hit enter, it says I'm searching for term 1, I'm searching for term 2. So let's show you how you can use the regular expressions module to actually make that search. So I'm first going to check if there's a match. So I call re dot and then the search function for that. And it takes two main parameters, the pattern and the string. So it scans through the string to find the pattern. So the first thing I'm going to do is say search, pass in the pattern I'm looking for, and then pass in the text I want to search for. And this returns true if it finds a match. So if we find the match, we're going to say match. Else we'll say print no match. Save this, and now let's run the code. And here we can say when I search for term 1, I find the match because it's inside that text. I'm searching for term 2, there is no match, it's not inside that text. So re.search, very simple function. You pass in the pattern you're looking for and the text you want to search, and you get back a Boolean value indicating if it's inside that. Now, often you don't want the actual Boolean value, you want the actual location. And if we take a closer look at this re.search, we'll notice that it doesn't actually return a straight Boolean value. It's actually not true or false, it returns a special match type. It returns a match object. And let me show that to you by getting rid of this. And let's take this all out of that if loop. And instead of saying re.search, I'm going to say match is equal to this. And let's get rid of that colon here. And then I'm going to say print the type of that match object. Save this, run our code again, and whoops, let's actually say term 1. Let's just do one of them here. So I don't need this patterns anymore. Save this, now let's run it. And look what we get here. Before we were treating it as just a straight Boolean value, but it's actually this special regular expressions match object. So what does that actually mean? Well, this match object returned by the search method is more than just that Boolean or none. It contains information about the match. So this object already contains information about where the match starts and where the match ends. And I can grab it just by saying this, match.start, close parentheses. And if I run this, I actually get back an integer. Whoops, that should have been outside of this type. Save this, and now run it again. Now I can see it starts at index position 22 within this string. And to prove that to you, let's make this text just say term 1. So I would expect the match to begin straight at index 0. So if I run this code again, I get back the number 0 here, which makes sense because my match starts at 0. And regular expressions also have the ability to split a string on a particular pattern. So if I say something like, let's say split term. So split term is equal to, we'll call it the @ symbol. Maybe we want to split something. I can say that my phrase, well, I'll just say email, is equal to user@gmail.com. And then instead of re.search, I can say re split, and then grab the split term, and then pass in the email address. And let's just print that out and see what we get. Save that, and comment that out, and then run our code. And note here, I get a split on that @ symbol, user and Gmail. And we've seen this before. This is actually built in already to strings, so you could just say split as a method off of this on the @ symbol. But it comes from the regular expression library. So just keep that in mind. It's already built into strings. Okay, so we learned how to find the match, and we learned how to do a split. Now, a lot of times there are more complicated patterns that you're going to be looking for. Or maybe you want to find all the instances of a pattern. And you can use re.findAll to find all the instances of a pattern in a string. Let me show you what I mean by that. I'm going to clear all of this and clear this as well. And I will say re.findAll. And note that Adam's actually helping us here. Again, it just takes a pattern in a string and returns a list of all non-overlapping matches in the string. So if I say something like match, and then let's say test phrase match in middle, and I actually print the results of this out so I can see it when I run my code. I will save this, run python notes.py, and here I can see it, I get a list of match. And if I add match one more time in there, run this again, I can see I get a list of 2 matches. So I could also just check the length of find all. Okay, so we learned about the very basics of regular expression library calls, that split, that search call, the match object. But what we're really going to be spending the bulk of this lecture when using regular expressions is what is known as the meta character syntax. And if you've programmed with Perl before, this sort of syntax is going to be familiar with you. But probably for the most of you, it's going to seem really strange at first. But don't worry, the idea here is not to memorize everything we show, but just to be able to use it as a reference. Come back to this lecture or look up regular expression plus Python on Google and be able to answer your own questions. But let's start off by actually just showing an example. And in order to show examples, multiple examples at once actually, we are going to create a helper function. And this helper function is going to be called multi-re-find. And what it does is it's going to take in a list of patterns and some phrase. And then it's going to go through those patterns. So for in patterns, what we're going to do is say print searching for pattern, and then let's say dot format, and I'll pass in pat there. And then I'm going to print re find all of pat in the phrase. And then I will print a new line because we're going to do this multiple times. So let's save that. And that's a function we're going to be using often. So let's start off with repetition syntax. And there are 5 ways to express repetition in a pattern. A pattern followed by the meta character asterisk is repeated 0 or more times. So for instance, let's get a test phrase here. And this test phrase is going to be sdsd ... SSSDDD ... SDDDD SDDDD. And you can copy and paste this from the notes so you don't have to listen to me talk. And then we have D, a bunch of S's, 3 dots here, and then S, and a bunch of D's. Okay. So the test pattern that I'm first going to test out here. So test patterns, again, it's a list. And I'm going to say SD asterisk. So here's my test pattern, and what this stands for is I want to find an S followed by 0 or more Ds. And keep in mind that kind of strange wording, 0 or more Ds. So what we're going to do now is call multi-refind with my test patterns, and I'm going to pass in my test phrase. Let's save this and run this and see what we get out. So if I scroll up here, I pretty much get back every instance of where there is an S. I get SD, S, SDDD, etc. Which makes sense because when you're using the asterisks, this returns this pattern, SD, followed by anything repeated 0 or more times. So essentially you're kind of asking for almost anything. Anything that starts with an S at least. So again, the key thing with this asterisk, and let me kind of separate this out so we can kind of get an idea here. It's going to be an S followed by 0 or more Ds. And the asterisk is attached to that D there. And later on we'll show you how to attach it to more than one letter. Okay, so that's not very helpful to just search for anywhere where there's an S followed by 0 or more Ds. So if we want it by 1 or more Ds, we put a plus sign. So if we look at the results here, this was 0 or more Ds, which basically asked for anywhere there's an S. Now if I run it with 1 or more Ds, I get back these values. And this makes a lot more sense. Here I get S, where it's followed by any count of Ds. Now, if I want it to be just 0 or 1 time, I can input a question mark. So I'm going to input a question mark here, save this, run it again, and now I get back where it was either 0 or 1 time. Again, not very helpful, but it is available to you. That's the question mark syntax. You'll probably want to know, how do I define a specific count? So let's say I want to know, when is it followed by 3 Ds? Where you use these curly brackets, pass in the number you're interested in, and then run the code. And here I can see wherever it was followed by 3 Ds, which happen to be 3 instances here. The first one here, second one here, third one here, and then fourth one over here. If you want to specify 2 numbers, maybe you're looking for 2 or 3 Ds, you can just pass in 2, 3 in this, run the code again, and we see here 2 or 3 Ds. In this case, there's no case, so let's try to make this 1. Run this again, and now I see 1 or 3 Ds. Great. Okay, so far we've shown those special characters, what the asterisk stands for, the plus sign, the question mark, and then curly brackets. Again, an asterisk followed by 0 or more, a plus sign followed by 1 or more, the question mark followed by either 0 or 1, and then the curly brackets where you can define the actual number or pass in a list of numbers. So far, if I show you what we've done, like SD+, that looks for S followed by 1 or more Ds. Let's say I wanted to find S followed by several letters, or several singular letters. So I want to know where S is followed by either S or D. So again, not together, but separate here. So let me know, is basically what I'm asking here, where S is followed by 1 or more S's or 1 or more D's. So if I save this and run this, we're going to get back a lot of results. So here are all the cases where the letter S is followed by either 1 or more S's or 1 or more D's. And this makes sense as far as our result because it basically shows you any statement that started with an S. So this statement started with an S here, started with an S here, started with an S here. Note that we don't start with an S until we get to the second letter, so that gets SDS, here, SSSS, and then SDDD. Okay, kind of weird and confusing, I know, but again, we're looking more towards being able to reference this instead of memorizing it. Now I want to talk a little bit about exclusion, and we can use the caret symbol for exclusion. And let me show you how we can do that. So let's find a test phrase that isn't so strange and do something like, this is a string, exclamation mark, but it has punctuation, period, how can we remove it? Question mark. All right, so often you're going to get a string and you want to strip it of all punctuation. And the way we can do that with regular expressions is by using the caret symbol, which I type like this, that caret symbol, Shift+6, to exclude terms. And for example, what we do is we end up passing it inside of square brackets. So square brackets, caret symbol, and then you pass in any symbols that you're looking for. So for instance, we'll look for an exclamation mark, a period, a question mark, and then we say plus because we're looking for 1 or more instances of that, and that's the test pattern. Okay, so now if we run this, I say python notes.py, look at the result I get back. I essentially get back a list, so it's searching for the pattern here, but because it has this caret symbol, it's going to remove anywhere. You can essentially think of it as almost like a multiple split call. So here it's saying find all, but that special character, the caret, lets it know that I want to essentially remove all this. And then later, if I have this list, I could just join it all back together or do whatever I wanted with those strings inside there. Okay, now let's discuss a few more examples that we probably won't run into during the course, but may be useful to actually see. One of those is a sequence of lowercase characters. You can just say lowercase a dash lowercase z, and this will return sequences of lowercase characters. So if I run this, now we see the sequences of all the lowercase characters. So this, you see the capital T has been removed. If I want sequences of uppercase characters, I just capitalize A through Z here. Run this, and then I get the capital letters. And there's a lot more you can do with this. Sequences of lower and uppercase letters, one uppercase letter followed by lowercase letters, etc. You can check out the notes for all those patterns. But we won't be using these too often. And then finally, you can use escape codes. There's special escape codes to find specific types of patterns in your data, such as digits, non-digits, white space, and more. And those are indicated using a backslash. So, like I mentioned, the escapes are indicated by prefixing the character with a backslash. Unfortunately, a backslash must itself be escaped in a normal Python string. So the way we do that is by making it into a literal value with the letter R. And this is where it kind of looks really weird because it almost looks like it should give an error. But we type an R outside of the string there, then a backslash, and then the special code for the escape. So for instance, D, and then we can say plus here. And this is the kind of regular expression that you look at it and it almost looks like a different language. You think it's an error, it's not going to be Python, but this will actually work. And this will return back a sequence of digits. So let me change the string to something more appropriate with, this is a string with numbers, put in some numbers there, and a symbol. And for the symbol, we can put something like hashtag. We will save that. And then if I run this code, I get back the numbers. So lowercase d is essentially a special character code saying search for those numbers or digits. If I want non-digits, that's a capital D. Run this, and I get back all the non-digits. If I want sequence of white space, that's a lowercase s. Again, all of these with the escape backslash and the R. And then I get a list of all the white space. Not super useful, unless I want to count how much white space there is. Capital S for the non-white space, so we can get the idea that capital kind of goes with non. So this is all the non-white space. If I want all the alphanumeric characters, those are letters and numbers, I can do a lowercase w, and that gives me back all the alphanumeric. If I want the non-alphanumeric, that's going to be something like the hashtag, I can do a capital W. And that gives me a bunch of blanks, and then I get the hashtag there. So those spaces are also non-alphanumeric. Okay. So in conclusion, by now, you should have a solid understanding of how to be able to reference the regular expressions. Now, there are a ton of more special character instances, and if I say something in the Django sections that we haven't covered yet, I'll be sure to kind of give a little extra explanation of what we're doing. We won't do anything super intense with regular expressions in Django. Essentially, we'll be just using them with URLs to kind of figure out, okay, am I going to .com/admin or /views/URL/ etc. Okay. Hopefully, you weren't super intimidated by this and you got a little bit of a good feel for what to expect when you're viewing regular expressions. Again, I don't expect you to memorize any of this. Thanks everyone, and I'll see you at the next lecture. To Part 6, Modules and Packages. You've seen Python import statements before, but you've probably wondered, how do they work and how do we create our own? It's actually quite simple, and we'll talk about it more when we actually reach Django. But let's find out the very basics of modules and get started with the editor. Okay, so here I am at the editor, and in this lecture we're basically just going to be showing you how you can create your own module and then import it into another file. So here under my project folder, I'm going to right-click, add a new file, and I will call this mymodule.py. And here it's just going to be a very simple function. We'll say func in module, close parentheses, and this just prints out I am inside the mymodule.py file. Save that, and then I will create a new file, and I will call this myprogram.py. And this is going to be representative of my program. So we can even do something like split left and right, here so I can see both of them at the same time. So again, there's my module and here's my program, and we can see they're both inside the same folder. So how can I actually grab code from my module.py and use it in my program? Well, there's various ways, and I'll show you the simplest first. We can say import my module, and note that there's other things here. So there's the built-in modules and the modules you use conda install or pip install with, and those are saved in a specific location in Python that you can always call them from no matter where you are. In this case, since I'm actually in the same folder as this py file, I can call my module. And then if I want to call a function from my module, I can say my module dot function module. And then I can say close parentheses to actually call it. So now if I say Python and call my program.py, I get back I'm inside my module.py file. And when you ran that file, you probably noticed that you got this pycache folder. And inside this pycache folder is some mymodule.c python code.pyc. And if you try to open that and read it, there's just a bunch of junk in here that you're not going to be able to actually see. And basically what happens is when you run a program in Python, the interpreter compiles it to bytecode first. And that's kind of an oversimplification, but essentially it stores that in the pycache folder. And if you look in there, you find a bunch of files sharing the names of the .py files in your projects folder, only their extensions are going to be .pyc. And essentially what this is, it's bytecode compiled and optimized bytecode compiled versions of your program's file. And if you're just a programmer, you can essentially just ignore it. All it does is it makes your program start a little faster the next time you run it. And when your scripts change, they're going to be recompiled, and if you delete the files or the whole folder and run your program again, they're going to reappear. Again, really you can just pretty much ignore this pycache file. But I just want you to be aware, and don't be surprised if you see it being created. Okay, moving along, let's show you the other various ways you can import from a module. So one way, again, import the actual file and then call it off my module. Another way is to say import my module as something. So you don't want to write my module every time you want to use a function for my module. So maybe you say import as mm. And then you can shorten my module here to just mm. And I save that, I run Python on my program.py, and I still get I am inside the module.py file. So that's another way you can call it. If you actually just plan on using a few specific functions from my module.py, you probably don't want to import the entire module. You just want to import a few functions. And in that case, you can say from my module, import, and then the name of the function or classes you want to import. So we say import function module. And then I don't need to call anything prefacing it or prefixing it. We'll just say function module, run this, and I can see I am inside of my module.py file. Now let's see one last example, and this is the example that I'm going to show you, but it's really not recommended you do this. You can say from my module, import asterisk, and this will import everything from my module, and you can just call function module just like we did last time. So this is frowned upon. You shouldn't really do this sort of asterisk behavior, but basically the reason for that is it kind of wastes a lot of memory in importing everything with this asterisk. Okay, so again, use the first three methods I showed you, and you can always reference the notes for that. But hopefully now you have a basic understanding of how you can create one py file with a bunch of functions or classes, and then call it from another py file. Thanks everyone, and I'll see you at the next lecture. To Part 5, Decorators. Decorators are an advanced tool in Python, and I want you to feel free to skip this lecture and come back to it at another time. Since we won't actually encounter decorators until much further on into the advanced Django material, it might make more sense for you to skip this lecture, and once you encounter decorators in the Django sections of the course, come back to this and review decorators. Otherwise, you may find yourself understanding the syntax, but being a little forgetful by the time you actually reach the use case of decorators. Okay, so again, we leave this lecture in this section because material-wise, it makes the most sense to leave it here. But as far as using it in this course, I would recommend that you actually skip it for now and come back to it when you see decorators mentioned again. Alright, with that all being said, let's get started. Okay, so to start off with decorators, they can be thought of as functions which modify the functionality of another function, and they really help make your code shorter and more Pythonic. And they're also used a lot in Python web frameworks, especially Django and Flask. Now, you don't actually run into decorators in Django until much further along in your learning of Django. But to properly explain decorators, we're going to be slowly building up from functions. So let's break down all the steps. First, we'll start off with a very simple function review. Remember, if we want to create a function, we can just say def, the name of your function, any parameters you want to pass, and then you can say return for instance, the number 1. And if I want to call this function later, I just say func. And if I want to print something, I can say print func. Okay, so if I save this and I run this, hopefully by now you have no problems with this. It returns 1. It all makes sense. Now let's discuss scope. So also remember from the scope lecture that I have global variables and local variables. So if I have the string s, global variable, and I save this, and then inside of this def func, I say something like take in s, and then I say print s, and I save this, and let's say over here, I just call func, func with s, excuse me, and then I run this, I get back global variable. And now, if I don't provide s as a parameter to the function, and instead do this, and run this again, it still works, because here, I don't have anything in the local namespace called s, so I jump back out and look for the global variable namespace for s, and I still find it, so I end up printing global variable. Now, if I redefine s to be equal to 50 inside of this, save this, run this, I get back 50 when I call function. But if outside of this, I call print s, save this, I get back 50 global variable. Remember, if I actually want to reassign not just the local variable s, but instead the global variable s, I have to say this, global s. Then I save that, run this again, and note back now I get 50, 50. So actually calling that global keyword calls in and tells me to affect the global, not just the local variable s. And there's actually a way you can grab a dictionary or a list of all locals variables and all global variables. And the way you can do that is inside of this function, just say print and then call locals. So locals returns a dictionary. Whoops. Locals, close parentheses. We're going to save that, and then I'm going to call the function here. So I can save this, run the code, and note here right now I have an empty dictionary because I don't have any local variables defined here. If I do define something like my local to be equal to 10, save this, run this, and now I see my local is 10. So that's just a convenient dictionary call to actually grab the local variables. Now if I say something like print globals, this will print out all the global variables, and there's going to be a lot here. So if I say python notes.py, I get this huge function of global variables. And that's because, not function, excuse me, a huge dictionary of global variables. And that is because there are a bunch of built-in things. So even though we haven't defined a whole lot yet, there are a lot of things. So there's notes.py is a global variable for the file. S here we saw is a global variable string. So I can also just call this like a dictionary. So globals, remember it's a dictionary, so if I call the key for S, and let's hashtag that out, I run this and I get back global variable. So printing globals at S finds this key value pair. Okay, so now that we remember what globals and locals are, let's start by continuing on with functions and function assignment. If I have a function called hello, and it takes in some parameter name, we'll have the default value be Jose, and I'm going to return hello plus whatever name is provided. And let's say I call print hello. I save this, run notes.py, and it says hello Jose. We can put a space in there so it makes a little more sense. Now I can also assign a label to a function, meaning I can say my new greet and set it equal to hello. And note that I'm actually setting it equal to the function itself. I'm not setting it equal to what the function returns. I'm not doing these parentheses here. I'm setting it equal to the function itself, which means I could say this, my new greet, close parentheses, and print this out. So let's do that. Let's print out my new greet, save this, run this code, and I see now I have twice hello Jose. Once from hello, and then since I define my new greet is equal to hello, I also get my new greet. And now that we understand how we can assign functions to new variables, let's continue on with functions within functions. Hopefully so far everything seems sort of like review. Now I'm going to create a function called hello again. Takes the default parameter, name, Jose, and right off the top in this function I'm going to print the hello function has been run. So if I ever call hello, I can see that the hello function has been run. So that makes sense so far. Now, inside of def hello, I will define another function. And I will call this function greet. And what this does, it returns, note it returns, it's not printing, it returns something that says this string is inside greet. So if I run python notes.py, I shouldn't expect anything else to be different because I don't actually call greet, I just define it here. And I'm going to do one more that says def welcome, and this returns this string is inside welcome. And we can save that. Again, if I run this code, I shouldn't expect anything different to happen because I'm only defining these functions inside of this function. I'm not actually calling them. Now, and pay attention here to the indentation. With the same indentation, let's zoom out a little bit so we can see all of this. So with the same indentation still inside def hello, what I'm going to do is say print greet. And then I'm also going to print welcome. And I'm going to say print end of hello. So now if I save this and I actually call the function hello, note back, I get the hello function has been run, I get the string is inside greet, so I actually define greet and call greet here, and then I define welcome and also call welcome, and then I get end of hello. And remember, because of scope, I cannot call greet or welcome outside of this. So I cannot say, whoops, I can call hello, but if I try to call welcome outside of the scope of this function, and you can quickly check what's inside this function by just collapsing that entire function here. So I run this, welcome, I will get an error. It says name welcome is not defined, because welcome is only inside the scope of the hello function. So keep that in mind. All right, so that's the basics of functions within functions, and I promise this will build up to decorators. Now let's talk about returning functions, something we haven't actually seen yet. So let's say this. Inside of my hello function, I will say if my name is equal to Jose, we'll put in lowercase Jose, return greet. So note here, I'm returning a function. We haven't actually seen that before. And then I will say else, return another function. We'll return the welcome function. I'm not saying return the call of welcome function. I'm saying return the actual function itself, meaning it's returning this entire function, not just the string itself. And now I will say this. X is equal to hello, close parentheses, and then I'm going to say save this. If I run python notes.py, all I see is hello function has been run, but I don't know yet what has actually been returned. So I can do this. X, close parentheses. If I run that, it says hello function has been run. And because this was just a return string, I need to actually print this out. So I can say print X, run this, and now it says the string is inside greet. So again, let's break down what's happening here. I'm saying if the default name is equal to Jose, which is the case, if name is equal to Jose, return the greet function. And the greet function is this entire thing. And the greet function just says, in itself, return this string. So then I set X equal to the result of hello, and by default the name is Jose, meaning I'm returning X to be equal to greet. So this is the exact same thing as saying X is equal to greet, except if it was happening inside of this function. So remember X, hello, and then I can call X, since it's now greet, and print out its result, which is this string is inside greet. Okay, really take your time with this one. This is kind of one of those jumps that might be a little confusing at first, but it's actually not so bad. Again, we're just returning a function, assigning it to a variable, and then calling that variable's function, and printing it out because it returned the string. Now we have one last concept to go over before we actually talk about decorators, which is a function as an argument. So I'm going to delete all this code and say def hello, and it will return hi, Jose. And then I'm going to create another function, we'll say other, and it's actually going to take in a parameter, func. And then it's going to print hello. And then it's also going to print func. We'll save this, and I'm going to pass in a function as an argument. So I will call my other function, and I will pass in the hello function. And keep in mind, I'm not passing what the hello function returns, I'm passing the function itself. So I don't have open and close parentheses at the end of hello. So if I run notes.py, I get back here function hello at this, which means if I actually run this inside of the other function with close parentheses here, now I should see hello, hi, Jose. So again, make sure you really understand what's going on here. I'm passing in a function as an argument. And then inside of the other function, I can call that function. So again, here we can see we can pass in function as arguments. Just like we could pass strings, numbers, dictionaries, etc., we can pass in functions themselves inside of another function and then play around with them. And now it's time to actually show the basic steps to create a decorator, which has to do with all of the concepts we just covered. So in the previous example, we essentially manually created a decorator. So let's show it and modify this to make it really clear. I'll create a function called new_decorator. And this takes in some function. And then inside of this function, I define another one that says wrap_func. Doesn't take any parameters. And it's going to print code here before executing func. And then here, I will execute func. And remember, I can call func because it's in that namespace. And then after that, I'm going to print func has been called. And then outside of all this, I'm going to return wrap func. And then I'm going to create a new function called func needs decorator. And I'm going to have it just print. No, it's not returning, it's just printing. This function, if I can spell, is in need of a decorator. So let's start off with a simple example, which happens when I call func needs a decorator. So if I just call that run python notes.py, it says this function is in need of a decorator. That makes sense so far. But what happens if I actually reassign it to say func needs decorator is equal to the new decorator with func needs decorator passed inside of it. So if I run this and then call func needs decorator, save that, run python notes.py, it says code here, well let's actually expand this a little more. It says code here before executing func. This function is in need of a decorator. Func has been called. So what happened here? The decorator simply wrapped the function and modified its behavior. And all of this code can be rewritten with the @ symbol. So again, what's happening here is mainly all in line 13. Remember, I have this original function that needed a decorator. It just does a simple print command. And I'm now passing it as an argument inside of new decorator. And inside of that, I'm calling it inside of this wrap function and returning that wrap function. And all of this can be done with the @ symbol. So let me show you what that actually looks like. I can say here, instead of these lines, so I will actually just comment this out so you can compare. So I have the func needs a decorator equal to new decorator with the func needs a decorator. Instead of that sort of reassignment, I can use the @ keyword and type in the name of the decorator I want, which is @new decorator, and then call a function, the func needs decorator. Well, I can actually call it, I would basically type this entire thing. So we can just grab this special keyword, that @ keyword, and this is the same thing as doing this. So now if I call func needs decorator, save this, and I'm about to run this, but remember what happened. I said code here before executing function. This function is in need of a decorator. Func has been called. I run this, and I get back the exact same thing. So the key point of all of we talked about is this, that if you ever had a situation where you would need to pass a function that needed a decorator into a new decorator and then reassign it, that's all going to be done with this simple @ call. So the new decorator with this @ symbol call is the same as doing this. And that's all we wanted to get across. Now you might be wondering, when the heck am I ever going to need to do something like this? Well, it's not really clear now, and it won't be clear until we actually show you an example with Django much further along in the course. But hopefully you actually watched that already and came back to this because you were confused on what the heck we were doing with the decorator. And I hope now this made it all clear. Okay, thanks everyone, and I'll see you in the next lecture. Part 7, Name and Main. An often confusing part of Python, especially as you begin to learn about modules, is this mysterious line of code that looks something like this. If name is equal to main, and then some code underneath it. Well, sometimes when you're importing from a module, you would like to know whether a module's function is being used as an import, or if you are using the original .py file of that module. Let's explore this some more, but make sure to check out the full explanatory text file that's in this parts folder. Let's get started. Okay, here I am at the editor, and to get started I'm going to make 2 files. I will make a one.py file, that's one.py, and I'm going to make another file that's called 2.py, two.py. And then I can say a split left or split right, and then I can see them side by side. Okay, so again, as I mentioned, sometimes when you're importing from a module, you would like to know whether a module's function is being used as an import, or if you're using the actual original .py file. So as we saw before, if I'm importing something from 2 into 1, and I run the 1.py script, I want to know, did that function directly come from 1, or was it imported from 2? And you can determine this by using that if name is equal to main statement. And when your script is run by passing it as a command to the Python interpreter, such as we've done with python notes.py, all of the code that is at the indentation level 0 gets executed. And functions and classes that are defined are well defined, but none of their code gets ran. Unlike other languages, there's no main function that gets run automatically. The main function is implicitly all the code at the top level. And in this case, that top level code is that of an if block. And that's the if name is equal to main. So let's actually show this. I'm going to, in my one.py file, say def of a func, and here I will say print func in one.py. And we can collapse that tree. And then I'm going to print top level one.py. Whoops. And then here I will say if, and note that I actually get this code automatically for me. So if underscore underscore name underscore underscore is equal to, and in string there, main, and then it says execute main. But we're going to delete that for now and say print one.py is being run directly. And then I can actually have an else statement with this as well. Else print one.py is or has been imported. So I will save this, and then in 2.py I'm going to write the following. I will say import 1, and then say print top level 2.py. And then from 1 I will say call one.func. And then I will say if, again, name is equal to main, print 2.py being run directly, and then else, and you don't often see an else, but it can definitely work with an else. We'll say 2 is being imported. Another, well, I'll just say it's being imported. Now, if we invoke the interpreter here with python one.py and I hit enter, notice I get back out top level one.py. One.py is being run directly. And if I run python 2.py, I get top level 1.py. 1.py has been imported. Top level 2.py, func in 1.py, 2.py is being run directly. And all of this works because of this name. So this underscore underscore name underscore underscore is a built-in variable which evaluates to the name of the current module. However, like I mentioned, if a module is being run directly, as in the 1.py or my script.py kind of deal, the name instead is being set to the string main. So whenever I run 2.py directly, then this variable, name, is set to equal main when I run it directly here. And thus, you can test whether or not your script is being run directly or being imported by something else. Okay, that's really all we wanted to get across here, that if you ever see if name is equal to main, it's basically a way of initiating the code in your main file, but also checking to see if you're importing functions from another file or calling them directly from the file you're currently in. So if you ever see this phrase or this line of code, don't be confused. A lot of times you will see it at the very bottom of a .py file, and then all the main logic of the code will come here. So often you'll see a bunch of functions in a file that says .py, you get this line of code, and you see a bunch of code logic that uses the functions and classes defined above it. So hopefully you're not intimidated if you see it again. Definitely read the notes for this, but as far as this course is concerned, that's really all you need to know. The basics of how you can set this up to determine whether you're using something directly or importing it. Thanks everyone, and I'll see you at the next lecture.